We are expecting this to be an incredibly exciting conversation on a very challenging issue related to monitoring of emissions from on-road vehicles. But before I go deep into setting the agenda for this conversation and the technical deep dive that we have planned, let me first introduce you the very impressive and experienced panel that we have with us today. So we have very senior regulators and well-known experts from India and other leading countries working on this issue very deeply and widely. From India, we have, and let me introduce you, Mr. Rajesh Kumar Sinha, Secretary, Transport in West Bengal. And we are delighted to have you, Mr. Sinha, here because, as we have been saying to everyone, that one state and city of Kolkata that has taken the lead to implement remote sensing, going beyond PUC and advancing on-road emission monitoring. So we are really keenly looking forward to hearing you today. We have Mr. Reggie Mathai, Director, Automotive Research Association of India. As all of you know, he really needs no introduction that this institution and he are very deeply experienced in the field of engine and vehicle testing. And in fact, Mr. Mathai, who is also the chairman of the Automotive Indian Standard Committee, and he's responsible for developing automotive standards in this country. So we are really looking forward to hear you, Mr. Mathai. Mr. Deepak Agarwal, advisor to International Center for Automobile Technology, ICAT. And all of you know that ICAT has spearheaded the pilot project in implementing the remote sensing program in Delhi. And he has very deep experience. And in fact, he's responsible for business development in automotive powertrain development for different OEMs. And he has also contributed a lot to the development of the rules for remote sensing in this country. The global team, and we are very excited to introduce you to the global panelists we have here today. We have Tim Delman, program lead of International Council on Clean Transportation. And he is very experienced and involved with the compliance and enforcement program and evaluation of real-world emissions and efficiency performance of vehicles. He's also playing a very important role in the real urban emissions, what is known as a true initiative, which is looking at how to apply real-world emissions data to support development of low emission transport policies globally. So there's a huge amount of experience there. Mr. Y.S. Yang, Senior Environmental Protection Officer from Environmental Protection Department, Special Administrative Region of Hong Kong. Mr. Yang, I mean, it's so impressive to see your work, the long years of experience in developing and managing in-use vehicle emission control aspects in Hong Kong, and how you have pioneered, which ever since we have started working on this issue, the whole advancement in like introducing dynamometer lug-down smoke test, and also the now remote sensing and dirty screening program in Hong Kong. And I'm delighted to introduce Mr. Lee Kung Sheng. In fact, a very old friend and association of CSE, and Mr. Kung Sheng, we are so excited to have you with us here, because we, as from time to time, we have been picking your brain that how is Beijing doing it? And when we are, and Mr. Kung Sheng, who has been the director of the Beijing Municipal Environmental Protection Bureau, and involved in the area of the vehicle emission pollution protection, and contributed to the standard setting for new light duty and heavy duty vehicles, and creating platform for emissions monitoring for the whole region of Beijing, Tianjin, Hebei region. So, Mr. Kung Sheng, we are absolutely delighted to have you here. We were also supposed to be joined by Mr. Satish Sahasrabudhe, Senior Advisor from the Transport Commissioner's Office, Maharashtra, but he just let us know that for personal some emergency and reason that he will not be able to join us today. But I must also tell you that today in the audience, we have a very diverse stakeholder group, professionals, experts, academia, civil society organizations, but and very important, and that brings out the excitement amongst the officials, the transport officials and other officials in this country, and their interest in this issue. So we have officials from the Transport Department, of course, West Bengal is here, but we have Tamil Nadu, Kerala, Delhi, Karnataka, Uttarakhand, Maharashtra. You know, that's the whole expanse of states from where transport officials have joined today in large numbers. We also have officials from State Pollution Control Board, Telangana, Gujarat, Himachal, Karnataka, West Bengal, and we also have officials from the bus transport corporations who are running buses in India. And we have from Andhra Pradesh, Karnataka, and Odisha. And so you can imagine from the whole breadth of this audience participation that we have today, that what is the level of interest that we have. So now what I'll do, I'll just flag off some of the key issues that just to set the context for the discussion today, that why all of us have met to discuss on-road emissions monitoring and its relevance in India's context today. I can see Mr. Mathai has joined. Welcome, Mr. Mathai. It's wonderful to see you. Looking forward to listening to you today. So I'll just share my screen and right. So very quickly, it is just to set the context. I'm not making any technical presentation, but to tell you and to the larger audience that why India needs to have this discussion today. Because for the last 5 to 6 years, all of us were so intensely involved with this whole conversation around how to improve the emission standards for the new vehicles. And as all of us know, that India has made this big leapfrog, the big jump from the Bharat State 6 emission standards to what globally we know as Euro 6 emission standards, the Bharat State 6. And with that, we have seen some phenomenal improvement from where we were and in the IC engine, the internal combustion engine. And if we understand today that how, because of that introduction, we have reduced the emission gap between petrol and diesel cars, though not eliminated, but also with the tightening of the standard, with the introduction of the new standards in terms of particle number, that has completely changed the paradigm of emission control in the diesel vehicles. So the diesel particulate traps, SCR, all of that is needed to capture and trap the tiniest particle and control NOx, though that whole entire ecosystem of emission control has changed very radically now in India. But the most important change that has happened, which had never happened in India before, is the whole focus on real world emissions. And as Mr. Mathai and Mr. Agarwal will tell us, that how these regulations have changed now, both for vehicle certification and also now, which is going to come for on-road in-use compliance regulations, that the entire focus is on how do vehicles emit in the real world as they are driven. And so with that, we are beginning to see big changes, and that's where the whole excitement is. And right now, all of us are waiting for the next round of BS6 reform that are supposed to happen in 2023. And we are hoping that by that time, we will be aligning almost fully with what the reforms that have also happened in Europe to make all these different parameters of the actual real world emissions more and more demanding and stringent. Now, so much has happened on new vehicles. And that absolutely and predictably takes to the next question, that what about the vehicles that are already on the road, the legacy vehicles, the Euro 1, 2, 3, 4 that we already have running in our cities. And all of us know that at this moment, the only scrutiny that we have is through this Pollution Under Control Certificate Program, which is applied to both commercial and personal, all segments of vehicles. And in addition to that, you do have a fitness and roadworthiness test for the commercial vehicles, but not for the personal vehicles. That happens after 15 years. And this is a very basic test that we do under PUC program that all of you know. It's a simple idling emission testing where you just measure the concentration of carbon monoxide and hydrocarbon in petrol vehicles, and we do the smoke opacity test in diesel, which is a very poor proxy for particulate matter, which is a bigger concern in diesel vehicles. But PUC, which is the only strategy for looking at on-road emissions today, we know it is plagued with a lot of challenges. And several audits now that have happened, and we have also been very deeply involved with several state governments in doing the audit of the PUC system. And that is bringing out that the poor level of compliance, that all vehicles do not turn up for tests, improper testing, the equipments don't function properly, the updated calibration certificates are not available in the PUC centers, lack of qualified and skilled PUC operators, problem of quality control, oversight issues, very poor data recording, very poor failure rate. Almost all vehicles pass the test. And the smoke density test for the diesel vehicles, absolutely ineffectual. PUC results, we also understand, as the experts tell us, they do not correlate well with the vehicle certification data. And increasingly what is coming out, that it is really not suitable anymore. Something that was created for the older generation technology is not suitable for the new generation technologies that are now coming in. And if you just want to have some visual images from the different audits that have been carried out, this is in different parts of the NCR that happened, you can even look at the state of the equipment, in the PUC. How diesel vehicle testing has remained a challenge, and the proper protocol is not met everywhere. There is enforcement challenge. Even fake softwares have emerged today. It's easy to get a PUC certificate. Improper testing procedures, all these are big challenges. Now, today, as part of enforcement, yes, the police and the transport department, they do check the vehicle drivers if they have the PUC certificate. But then they only look at the paper. But no one is reading the fine numbers and the fine line in the certificate. So imagine a certificate for a diesel vehicle where the maximum RPM, that is the speed of the motor, that is actually lower than the idle RPM. Okay, the number is there in the certificate, but we have not created that knowledge and the capacity in the enforcement agency who can spot it and catch it, right? Also, now as we are moving towards BS6 and other technologies, we are finding that perhaps there are also issues with sensitivity of the instruments. So for the BS4 vehicles, on some parameters, you're actually getting zero values, right? So clearly, a lot of things are not okay and not adequate anymore. More PUC reforms have followed very recently in June 2021 to make it more robust, more enforceable, right? And that's where most of the transport departments are moving towards. So we have now talking about uniform PUC certification format, linking PUC database with national register, concept of rejection slip if you don't pass being introduced for the first time. Earlier, we did not record a failure. So it was very difficult to know how many vehicles had actually failed the test. Now more IT-enabled enforcement. So hopefully this will help to strengthen the current system. But the bigger question that we're asking also, that even with PUC, the current system, so much digitization has happened already, right? But this data that is available in the central servers are not usable for the program improvement. So even with uniform software for recording PUC data, there is no system for maintaining and analyzing backend database because those systems have not been created or even asked for. several important fields such as the year of manufacture, register, vehicle type, fuel type, we don't even record those, right? There is no system or capacity for data analytics to provide the feedback to improve performance. So clearly understand that so much of, there is huge investments happening today to make all our systems IT enabled. Digitization is taking off, data is getting recorded, but this data cannot be used because we have not created the right protocol for the usage of that data. So from here, therefore, we are establishing the context that where do we go? And because there is clearly a mismatch today between the current system and the new generation regulatory requirements for real-world emission surveillance and control. So POC can be strengthened, be done better for the old legacy vehicles, but what do we do? Some steps have been taken in India, and ARAI is here very deeply involved with setting up of these centralized INC centers in different parts of the country. And these are automated, more advanced centers for testing fitness in commercial vehicles. Now we need to consider that how can this be leveraged so that more advanced emission testing systems can also be linked with this investment. So looking at it from that perspective, therefore, our question today is that how do we keep meet the next generation challenge, and how do we keep our vehicles low emitting during their useful life on the road? That is the fundamental question that we are raising. We have a global panel today, and what we really want to learn from them, that everyone, even in India, all of us have heard about the Volkswagen scandal, we have heard about the Dieselgate. That had gripped the world. And I'm glad today Tim from ICCT is here, because it was your testing, the ICCT testing of the real world emission that had led to the expose of the Dieselgate and the Volkswagen scandal, right? So, but then what is important for us to understand that after that Dieselgate, there was strong regulatory response across all major global markets. And a lot of regulatory reforms came about, and mainly focusing on real-world emissions monitoring and control and different methods of doing it, and improving the certification system at the same time. And that's what we would really like to understand from you. Now, in India, has anything happened beyond POC? So as you can see, we are now beginning to take those small steps. So OBD, which has already been introduced in Indian vehicles. So the first step taken for the POC is the notification saying that the POC centers need to look for the malfunctioning light on the dashboard. And if the light is on, the vehicle should be returned for repair and brought back for retest. This is what we have started doing. India has also adopted the vehicle recall program. But what is more exciting, and the reason why we are discussing this today, is the step towards remote sensing. And let me tell you that the opportunity in India today is that today, under the National Clean Air Program, 122 cities are implementing clean air action plans. States where we are, we know that they have already included remote sensing as part of their clean air action plan. West Bengal really takes the lead. Kolkata has already implemented. But if you look at the other non-attainment cities in West Bengal, Asansol, Barakpur, Durgapur, Haldia, and Raniganj, all of them have included remote sensing as in their plan. And they have actually mentioned that the current program in vehicle, that is what will be, that the learning curve for them. Similarly, Mumbai Clean Air Action Plan has also done this, and now very recently their Committee on Transport has taken this on board for further detailing. Orissa, Bhubaneswar, they have included this, and in Delhi, as you all know, that Supreme Court has already mandated implementation of the remote sensing program. And in this, therefore, to understand what is happening in India, the first generation remote sensing had actually started in 2004-05, when ARI was looking at ways of further developing the INM program in India. Small pilots had happened in Pune and Delhi, but then there were many challenges at that point of time. The technology was not mature, there were challenges in terms of measuring emissions from 2 and 3-wheelers. And in fact, if you look at the data that is available, that out of the total measurements in that pilot scheme, 92% of total results were for the light duty vehicles, and the 78% for the buses and trucks were found valid. But for 2-wheelers, it was only 28%. Now, it had happened then, but then it was discontinued. Nothing came out of it after that. There was a lull and there's a discontinuity. Nothing happened. The whole issue again got revived when in Delhi a few years ago, when there was a strong demand for improving the on-road emissions monitoring. And that's when the EPCA, which was at that point of time the committee recommending to the Supreme Court, when they had taken this issue up with the court, there was a very strong support from the Supreme Court. So if you look at these 3 critical directives from the Supreme Court at that point of time, and Mr. Sinha, you will be happy to know that in the Supreme Court directive of May 10, 2018, the court actually observed that the remote sensing screening has been found to be extremely effective in Kolkata. And it's of great utility. And it asked, therefore, Delhi to adopt it. So you actually set the precedence. So that became the reference point for them to look for this strategy for Delhi as well. Then in July 2019, by that time, ICAT, and Mr. Agarwal is here, he was involved with that pilot project that happened in Delhi, and the report was submitted to the Supreme Court. And the court again said that ICAT has found this to be an effective method, and now EPCA, the committee, should look into that report and recommend the way forward. And EPCA certainly upheld that and saying that this is really going to be transformative if Delhi adopts this strategy. The final directive from the Supreme Court then took all the recommendations of EPCA on board and issued a notice to the Ministry of Road Transport and Highways and also to the Department of Transport, Delhi, for the implementation. And if you look here, therefore, that the steps were outlined for the Ministry of Road Transport. It had asked for the plan for implementation, rules under Central Motor Vehicles Act to define the scope of the use of remote sensing, to notify gross polluter threshold, that how do you apply the threshold to identify the gross polluter, provide technical guidance on designing of the program, global tendering for purchase of 5 machines for Delhi, and finalization of site and sampling plan, and all the guidance for the industry. So this was for the Ministry of Road Transport and Highways. And for the Department of Transport, they were asked to implement, do the global tender, even assess the availability of the equipment, capable of monitoring all these parameters, do site selection, create data networks, software, all the program detailing were asked to be done. But of course, this could not be taken forward because this awaited the action from the central ministry first. So clearly, this is the mandate today. But the good news today is that the Ministry of Road Transport and Highways has now framed the AIS rules. And this notification is there. And I'm not reading this out, but it has defined the full scope of that program. The question is, how do we take this forward now for implementation? Now, today, when we are looking at India, the only city that is already implementing, and no one knows that Kolkata has been implementing this for last more than 10 years. And the directive had come in 2009 to the High Court. And since then, this has been going on. So today, I'm not going into the details of it because we have Mr. Sinha to talk about this. But this is the only instance, an example, and a long example that we have in this country where this has been implemented. Finally, what I would like to say that today, when India is going to frame the new program, we have to tap into the global learning curve. And that's why this international panel today is so important for us. So as you know, that there has been very rapid advancement across all major markets of the world. And starting from spotting and chasing visibly polluting vehicles, and then to take them for compliance testing for short test on dynamometer, which Hong Kong has kind of started so early. And then you have the small volume testing on dynamometer. Today, the world is moving towards using portable emission monitor for real world testing emissions as vehicles are being driven on the road. But these are still low volume testing. that are happening. But where the large volume testing is possible and happening is remote sensing, which allows you high volume fleet-wide screening. And that's what we will be discussing more today. And linked to that is the whole OBD monitoring and remote OBD monitoring, which Beijing has done. So all these are great experiences in front of us. And we understand that with the application of this new technology, the new paradigm shift that we are talking about today, that how this new approach is going to open up new possibilities for us. We can, and this is what we will hear from the panel today, that how it is possible to do fleet emission monitoring, identify the worst polluter for the testing and enforcement. More pollutant and parameters can be brought under the scrutiny. This remote sensing measurements are going to be more representative of the real world emissions. This will enable surveillance and catching of emission fraud in the real world. Assess performance of the vehicle technology, which are evolving constantly in response of the new mass emission standards. And this will also can also help to support implementation of new policy measures. And more steps are being taken today to standardize the systems, its application globally. And that's what we will hear very keenly from all our presenters today who are here. So the final slide for me, just saying that based on all this conversation and our understanding that how the new trajectory is evolving, we have to identify the next steps in India. If MORTH rules are here, then how can we think of implementing that, taking that as the basis and the guidance and the guidelines for the city and standardize the system for implementation? We need to have a roadmap for implementation in cities. Can we have selected champion cities who can implement? Kolkata is already doing that. They can continue to take the lead and have more champions to demonstrate. And how do we develop this as part of our compliance system and also penal and enforcement action around it? And finally, all of this will be possible if we can develop capacity and infrastructure for data analytics and feedback to the system. We need for everything that it allows you to do: fleet profiling, clean and dirty screening, use of data to develop even real-world emission factors, improve accuracy in emission models, forecasting. So much is possible. And more important, all the clean air programs that the cities are looking at today, that you can actually begin to validate the effectiveness of those programs in India. So that's where our excitement is. And this establishes the reason why we are doing this discussion today. And so keeping these issues in mind, keeping this context in mind, the relevance of this conversation today in the context of how the rules, regulations, Supreme Court directives, etc., have evolved in this country, and all the technological and the technical discourse and exercise that have started, we have to enrich that and inform that better. So therefore, to take this conversation forward, let me now invite, we want to begin this conversation with the only example of real application in India, which is Kolkata. So I would like to invite Mr. Sinha, Mr. Rajesh Sinha, Secretary Transport, West Bengal, to please share this very exciting, the program that you have already implemented.
Thank you very much. Am I audible?
Yes, we can hear you.
So I'll just make a small presentation. In fact, you have made my life much easier by covering all the aspects of the remote sensing device application and everything. We've also covered the Supreme Court guidelines, the NGT guidelines, and the MVA Act and rules, which are applicable for this purpose. So I'll just cursorily run through what presentation is there. Can I ask you to please allow me to share the screen?
Sukanya, can you?
Are you able to see it?
Yes, we can see your presentation.
This is the small presentation on on-road motor vehicle emission monitoring and enforcement in Kolkata. I am Rajesh Kumar Sinha. I am presently in charge of Transport Department as Secretary. So this is the profile of Kolkata from the point of view of the Transport Department. So we are the third largest metropolitan city in the country. We have a population of about 15 million in an area of 1,886 square kilometer. That makes about 26,000 people per square kilometer. We have all modes of transport in operation, starting from handcart to the metro rail and suburban rails in Kolkata. We are connected by International Airport, Kolkata Port, which has also international operations, and there are 5 number of railway terminus stations. This is the number of vehicles registered in Kolkata metropolitan area. You see that in 9-10, we had about 50,000 vehicles registered every year, which has come to about 75,000 now. So in all, we have about 1.1 million vehicles on road as of now. If you see the vehicle population over the years, in 2010, we had about 411,000 vehicles, coming to now about 1.103 million. So the population of vehicles has more than doubled in the last 10 years. So this is the year-wise trend of monitoring of pollution in Kolkata. Various pollutants have been measured by this is taken from the Environment Department. We have just shown PM10 and NO2 from 2013-14. It is almost constant. In fact, PM10 has increased, but NO2 has decreased from the earlier levels. This is how it fluctuates, starting at a higher level in the months of winter, goes down during the monsoon, and again climbs back to the higher level. So use of RSD in Kolkata started in the year 2009, when we had first purchased the device in that year. And the device is being operated by a private party, which is selected by us. He maintains and operates the device on our behalf. So the device checks out emissions without stopping the vehicle on the road and records pollutant levels of carbon monoxide, hydrocarbons, NOx, and smoke. It also takes a photograph of the vehicle with a high-speed camera, whereas the registration plate of the vehicle is captured. The capacity of device is that it can detect pollution from about 3,000 vehicles in an hour, working in broad daylight. It takes about 50 readings of pollution levels from the moving vehicles from one vehicle in a second, less than a second, and measures from all types of vehicles, petrol, diesel, CNG, or LPG. And the accuracy and consistency are very good. We regularly calibrate it. There is a standard solution of various gases, which is used to calibrate every 2 to 3 months. The license plate number is captured and the tailpipe emission is captured. I can show you how it looks. See, this is the instrument, this is the camera. The vehicle is moving in line from here, and this is automatically capturing. Once the vehicle is captured like this, you can see that the speed, acceleration, the CO level, CO2 level, hydrocarbon, NOx, everything is captured with the time and date of the vehicle and the registration number. After this, we issue a show cause notice to the offending vehicle in a format where we also give the vehicle photograph and the emission which has been recorded by us, and ask them to show cause as to why we should not, they should not be brought to us within 7 days with the corrected emission levels to our RTO office. If they come within 7 days with the corrected emission levels, well and good. If they don't, then we fine them as per the MV rules. It is the 1,000 rupees in the first violation, and in second subsequent offense, the penalty is 2,000 rupees. This has subsequently been increased in the 2019 amendment of the Act, but our government has yet not introduced that amendment. So right now we are penalizing 1,000 rupees to offending vehicles in the first offense and 2,000 rupees to the offending vehicles in subsequent offenses. Average monthly penalty that we have realized using this machine is about 8 lakhs during 2019-20. Most of the period, in fact, we had lost due to COVID. So despite that, the realization is not that bad. On an average, we test about 52,000 vehicles every month and issue notice to about 10% of that. 10% of that vehicles are generally found to be offending vehicles. This has helped us both in enforcement as well in planning. You can see that this is the way we used to do by using the manual method, when the traffic police would stop the vehicle and check the vehicle's emission through a device on the road. There we could launch about 36,000 to 50,000 prosecutions every year. The total that in 4 years we could launch about 135,000 prosecutions. But you see that after introduction of the RSD, this has increased tremendously. Almost 200 times more prosecutions have been done using RSD than the manual method. So right now we are doing about 88 lakh to 90 lakh pollution enforcement prosecutions yearly. We have checked about 51 lakh vehicles over the last few years that is there in operation with us. So it also helped us in making planning for the future as to how to go about removing the older vehicles and what is the pollution level from older vehicles as compared to the newer vehicles. You can see one such typical analysis here. Overall diesel vehicles which are detected on road, 34 vehicles out of 1,000 are found to be polluting, of which 10-year-old vehicles are more than 68 and less than 10 years old vehicle are 32 per 1,000 vehicles which have been found to be polluting. So there are also divisions between transport, non-transport, goods vehicle, taxi, buses, everything. So this helps us in the planning for the future. This is one typical analysis for petrol vehicles. We have found about 37 petrol vehicles polluting, which is there on the road, which is out of 1,000 vehicles, of which more than 15-year-old vehicle are 100 plus and less than 15-year-old vehicle are 36. So this helps us in all kinds of planning and decision making. So this is how we have been doing, and that's all I have for you to present. Thank you very much.
Thank you so much, Mr. Sinha. I mean, it is so encouraging to see hard data, from the program. And it kind of convinces that how you are already on the right track and why other cities need to follow this. And I mean, even though, I'm not doing question answers in between, but I still cannot resist from asking you that therefore, what plans do you have to expand this program further, keeping in mind that other cities in West Bengal will also be doing this? So how do you want to further strengthen and take this forward? And you started doing the data analysis already, and that is a very powerful tool. So how do you want to kind of further, take this forward?
Yeah, we have been discussing this with our government, and now we have decided that we'll get more of these machines and we install it in various cities. So right now we have a plan to introduce at least 2 machines immediately in a buy, own and operate mode. We'll not buy the machines. We'll ask the private party to supply the machine and operate it for us against a payment. So this is how we are planning to do. And this, I believe that by the end of this year, we'll have 2 more machines in place. And depending on the further requirement and further analysis of the data from various other cities, we'll think about introducing more machines.
Well, that's so encouraging, and we will love to engage with you in future also as we keep this, take this forward in other cities as well. So, Mr. Sinha, we certainly hope that you will stay for more discussion and also to listen to the other panelists who are going to share the experience with us right now. I'm here. Yes. So thank you very much. So from this specific case study in India, we want to have one global understanding of what's going on. So Tim Delvan from ICCT. So Tim, would you like to give us that broad perspective on how these strategies are advancing globally?
Thank you, Anamita.
Yeah.
Yeah, and I hope my presentation is coming through, but I want to start with just thanking CSE for organizing this very interesting webinar. I think Anamita did a great job of demonstrating the importance of discussing approaches for real-world vehicle emissions monitoring and control. And today here, I'm just going to try to give a brief overview of some of the ways in which other countries and other regions have adopted specifically remote sensing as a method to monitor real-world vehicle emissions, and also to discuss some of the ways in which that data can be used for a variety of different purposes, even going beyond just looking at high emitters to perhaps other policies and actions to really drive low emission transport. So I think we had a great introduction from Anamita about the reasons why we're interested in real world emissions. But I just wanted to reiterate that point here by showing some data from the ICT comparing the real world emissions of different European passenger vehicle groups separated by fuel type with diesel on the top and gasoline on the bottom. And then each figure shows a separate Euro standard. So we can see here, especially for diesel cars, real world emissions, which are shown by the larger plumes that are colored in, have emissions that far exceed laboratory limits. So this is kind of at the core of the Dieselgate scandal, especially for diesel vehicles in Europe and other countries that have high rates of dieselization, has led to higher than expected real world emissions. And those emissions have detrimental effects on both air quality and human health. So understanding what emissions are in the real world and taking actions to address those, I think are very important points. And some of the topics I'll be talking about today kind of go over different ways that regulators, government agencies, and other research organizations can use these methods to provide insight onto real world emissions. So we've already discussed remote sensing technologies. This is one of several different types of methods that can be used to assess real world emissions. I think we've had a good description of the technology itself. These graphics just show two different setups for remote sensing instruments. On the left is a typical crossroad instrument, similar to what's being used in Kolkata, where you have a source and detector module measuring the emissions from a vehicle, a camera to record the license plate of the vehicle, as well as a speed and acceleration detector in order to get some information about the operating conditions of the vehicle at the time of the emissions measurement. And on the right shows a different type of instrument that's making the measurement in a similar way, only in this case, the instrument's placed above the roadway and the light beam that's used to measure emissions goes down vertically through the exhaust plume. So the advantage of the setup on the right is that it is a little bit less sensitive to the location of the tailpipe and may be better suited to getting a wide variety of different vehicle types with one setup. But both types of instruments or both setups fundamentally work in a similar way and measure the same core set of pollutants, which is shown on the bottom of the screen. So again, Anamita, I think, did a great job of covering some of the ways in which real world emissions data can be applied and inform policies and actions to control and use emissions. So I just have a summary of some of those key areas here, areas in which real world emissions data, remote sensing data can inform things such as high emitter identification or clean screening programs, fleet screening, so getting an idea of the emissions from the larger fleet, primarily for market surveillance activities. So in this case, to identify perhaps vehicle models that are systematically underperforming relative to expectations. Can also be useful in identifying cases of tampering, especially with modern control systems. They're only as effective as kind of the only going to provide the emissions reductions as long as they're maintained and operating effectively. So any instances of tampering one can lose the emissions benefits that you get from things like DPFs and selective catalytic reduction systems. The data collected during real world studies can, as Anamita mentioned, can support new policies such as low emission zones, and also can be used to track how effective policies are in the real world. So making measurements over a long period of time, similar to what Kolkata has been doing, provides a great rich data set to look at, are these policies that we're implementing actually having an effect in the real world? Finally, it can be very useful in raising public awareness. So something we found in our own work is that kind of letting consumers know about the real world emissions of the cars that they own or they're considering purchasing can be an important consideration as they're deciding kind of whether to buy a new vehicle, and if so, what type of vehicle to purchase. On the right is just an example of kind of a conceptual diagram of where we see kind of remote sensing fitting into a broader in-use vehicle control program, where the real power of remote sensing is its ability to measure many vehicles on the road. So here, kind of you can get sample sizes up to hundreds of thousands to millions of vehicles. And in doing that, you can identify a couple things identified here. So individual high emitting vehicles, suspicious vehicle models, or individual low emitters. And with that knowledge, with that data, you can take action, whether it's follow-up testing with other types of methods, PEMs or chassis dynamometers, to get a more detailed assessment of what's causing high emissions, or similar to what Kolkata presented, taking action when you identify high emitting vehicles in order to get them off the road or have their owners perform the necessary maintenance to address those high emissions. So now the rest of my presentation, I just want to give some examples of ways in which other countries are using remote sensing to identify some of those applications where that information on real world emissions has been most useful. So this map just gives an overview of kind of an analysis the ICT did a few years ago, looking at countries and cities that had used remote sensing since 2010. And this map is current as of 2018. So you can really see kind of the broad swath of different countries and regions that are using remote sensing. And it's for a variety of different purposes, but it's definitely a well-established and adopted technology when it comes to measuring real-world emissions. I'm going to start here in the US just to highlight a few programs that are in place in several states in the US. And these are clean screening programs, which are similar to high emitting vehicle programs, only they work to benefit the drivers of the cleanest vehicles in the fleet. So in this case, remote sensing is used to identify low emitting vehicles, and those vehicles are then exempted from annual garage-based inspection requirements and are able to re-register their vehicle on the basis of the remote sensing measurement alone. So in this case, that acts as a benefit for drivers in that they don't have to take the time to take their cars into actual physical inspection station. A few states also in the US implement high emitter identification programs as well. And one thing I want to highlight is that although kind of in the US, these states are using these for a very specific purpose to support their inspection and maintenance programs, they're also developing very rich data sets that can be used for other applications. So this gives an example of work that the ICT did through the TRUE initiative to collect data from the states that are implementing clean screening programs and to analyze that data to provide a broader picture of the fleet emissions in the United States. So we developed a database of close to 60 million remote sensing records and use that for a variety of different analyses, including what's shown on the left, which is the trends in light duty vehicle emissions in the US for 3 different pollutants. So again, showcasing the ways in which this real world data can provide more insight into, in this case, the effectiveness of different tiers of the US light duty vehicle emissions control program. Remote sensing and roadside monitoring will continue to be used in the United States. California is now discussing the next stage of their heavy duty vehicle inspection and maintenance program. That will rely primarily on OBD, but it also include roadside emissions monitoring network. So this will use remote sensing devices set up throughout the state to monitor the in-use emissions of heavy duty vehicles and flag instances where those emissions are above expected levels. So that's in development now, but a very nice extension of the use of remote sensing in emissions monitoring programs. I'm going to touch here on China. I'm going to save the detailed discussion for my fellow panelists from Beijing, who will provide much more insight, I'm sure, into all of the great things that China is doing with remote sensing. I'll just highlight here that China implemented a national remote sensing regulation in 2017 and has built up a very extensive network of remote sensing monitoring station to support in-use control programs. They, as of the end of 19, had about 2,700 remote sensing instruments and monitoring stations in place, and had collected upwards of 270 million measurements of individual vehicles in 2018. So I think kind of just the scale of the program in China is well beyond anywhere else. So I'm be very interested to hear from my fellow panelists about all the interesting things that they're finding with the program. Moving on to kind of give a glimpse of South Korea is another country that has been implementing remote sensing to supplement their periodic inspection program. In this case, since around 2013, in-use limits are set for gasoline and LPG vehicles. And as the graph shows on the right, they're collecting between 1 to 2 million measurements each year. The government of South Korea is using the remote sensing measurements primarily to identify high emitting vehicles, but they're also using the data to evaluate the status of in-use emissions, to develop their future actions and policies, to try to address those emissions, as well as to, as I said, shape emissions control policies moving forward. In Europe, I wanted to highlight some of the work of, Anamita mentioned, the Real Urban Emissions Initiative, which is a partnership of the ICT and the FIA Foundation. It was founded in 2017 with the purpose of supplying cities with real world emissions data on their fleets in order to equip them with the knowledge that they need to develop new policies and actions to address high emissions in their cities. So through the TRUE initiative, we have led remote sensing testing studies in 4 European cities to date, starting in London, in Paris, then last year collecting measurements in Brussels and Warsaw. And in each case, these are programs intended to raise awareness about real world emissions in these cities, as well as to provide data to the cities themselves to support actions. So just one example of kind of the utility of programs like these is from our London testing, we're able to show that the iconic diesel taxis that are in use in London, when they were powered by diesel engines, had emissions well above comparable diesel cars and significantly higher than emission limits. So it's shown here in this graph with the orange bars relative to the blue bars, which show typical London diesel cars. So the mayor's office was able to use this data to support new actions to promote faster transitions away from these higher emitting diesel taxis and transitions to zero emissions capable alternatives. The remote sensing data that we're collecting in Europe has also been very effective for other applications, including market surveillance activities. So looking at the emissions of specific vehicle families. So if enough data is collected, we can start to see differences in the performance of vehicle families, even in a common Euro standard or emissions control standard. So the plot on the right here shows our estimates of the real world emissions for individual Euro 6 vehicle families. So two things to highlight here is just the difference between diesel and gasoline emissions. Even with the implementation of the Euro 6 standard, diesels were emitting at several times higher than comparable gasoline cars. But we can also see with the diesel vehicles a significant spread. So all Euro 6 diesel cars aren't the same. So some manufacturers are producing vehicles that are performing much, much better than others. So having this information helps regulators to understand where to more efficiently target their market surveillance and service conformity resources and run those programs perhaps more efficiently by incorporating this real world emissions data. And along the same lines, kind of having that information at the individual vehicle level, the TRUE initiative has developed a rating scheme in order to inform consumers of the relative emissions performance of the vehicles that they own or are considering buying. So an example of the information coming out of that rating scheme is shown on the bottom of the plot here. And finally, I'll just highlight, it's been talking a lot about remote sensing, but when we're talking about kind of in-use vehicle control programs, periodic technical inspection, with the advent of diesel particle filters, folks have found that traditional opacity monitoring may not be as effective in identifying instances where particle filters aren't performing as effectively as they should be. So several European countries are now moving towards incorporating particle number testing as part of their PTI programs. So that the particle number measurement is more sensitive and better suited to identifying cases where DPFs are either malfunctioning or have been intentionally tampered with. So our testing program in Brussels involves some tailpipe particle number testing to evaluate the new sensors that are coming online to do these measurements. And we found that about 5% of the tested diesel cars that had DPFs installed had very high particle number emissions. And that small group represented 90% of the total particle number emissions from that category of vehicles. So just really showing kind of as the fleet gets cleaner, trying to identify and take action on the small number of high emitting vehicles will be very important. And finally, I just wanted to mention, in addition to our work in Europe, the TRUE Initiative has also recently done testing in Jakarta, showcasing how remote sensing can be used in cities where you have a very diverse traffic fleet. And I also wanted to highlight work in Mexico City, where, as you can see on the timeline here, testing has gone back to the early 1990s, has continued through present day, with the city using remote sensing as part of their fleet monitoring activities, and more recently in high emitter identification programs. And then I just wanted to leave everyone with kind of insight into kind of where we see this technology going. And I just wanted to highlight a few research programs that are ongoing now. On the left, what is called the City Air Remote Emission Sensing Program. So that's an EU Horizon 2020 funded program that's aimed at developing remote sensing and other similar real world testing technologies, and how to better incorporate those measurement methods into existing inspection and maintenance or periodic technical inspection programs. So with that, I will thank everyone for their attention, and thank you again to the team at CS&E for organizing this webinar. So I'll just leave my summary slide up here, the purpose of time. So thank you, Anamita.
Thanks a lot, team. I mean, this is really a very good overview of what's happening around the world and what we can learn and the scope of application. So I'll come back to you because I'm also keeping an eye on the time and we are really running short of time. So now we come back to India again. And Mr. Mathai, if you can tell us about the regulation developments around the new strategies for on-road emission management that ARAI is so deeply involved with. So, Mr. Mathai.
Yeah, thank you.
Keep the time down in such a way that, because I think we have 3 more speakers. So yes, Mr. Mathai, please go.
Yeah, I will be very short and crisp because I know most of the aspects have been covered by my previous speakers. So I will just touch upon what we have been doing and what we are thinking means about the emission measurements on the real driving conditions. So the AIS specific standards for the remote sensing device is in place, and the studies you have already mentioned, and I think Mr. Deepak Agrawal will be can present more details into it because they were spearheading that studies. But coming to the BS6 vehicles and the real driving emissions, now for all type approvals, the real driving emissions are being monitored. Means it's a part of granting the type approval, although the limits are not defined as such, but as a part of the data generation, we are doing that. Along with that, the conformity of production means COP testing as and when these vehicles come into that zone means after a period or based on the number of vehicles they are being produced. So these in-use vehicles are also being tested for the RD emissions, so using the PEMS. So this is a continuous program that is going on until we finalized on the conformity factor. So I think if we decide it earlier, this testing we will be discontinuing, and then we will have the implementation, means what is to be done based on this data that has been generated or what is actually happening. So till then, the monitoring program will continue, and that is, as you rightly mentioned, into 2023. the RDE has to be implemented. So by that time, we believe that the conformative factors will be in place. So that's all about the emission measurements and real driving emissions that we are doing as of now. Maybe on the INC centers, anyway, you have touched upon, maybe these are also coming up in a big way, the inspection and maintenance centers. Now, various governments have taken the initiatives, just like West Bengal has taken a lot in the RSD. Certain state governments are going out in a big way in setting up these places, like 10 to 12 of them, while some are going in 1 to 2. So these are also going to be in place in next 2 years' time, so because these orders are placed. But these are again looked into specifically for the commercial vehicle segment as of now.
Yes, Mr. Mathai, are you?
Yeah, it's over for me from my side.
Okay. You would like to add anything to the new AIS rule on remote sensing?
See, that rule has been put into place from March 2021. The AIS has been put into place, but it defines on the product specification and the program guidelines. But as such, it does not, currently it is on a monitoring phase again. We have not put any values to it as of now. And moreover, this equipment, I think Deepak can add later on also on that. It can, comparatively, it can give the performance and can surely say which is a more polluting sort of a thing. But again, you have to take it for a real test to understand how much more it is being polluting. Because those values were never, during the AIS discussion, it was never, we couldn't come into a common understanding on that. But yes, what equipment has to be used and what are the emission parameters that can be monitored, this has been put into in the standard as such.
And do you see an opportunity for introducing short dyno test in the new INC centers as a complementary strategy for remote sensing to address the worst emitters?
I think the first phase currently, this is not being considered, but as and when we have to really have a look at the remote sensing data that is being generated. I really appreciate Kolkata going ahead with that, and if such efforts are being put into place, and if need be, then we can think of it, because the comparative performance, as I mentioned, the comparatively it can give you a indication. And so if there is need to be an actual one, then we can think on the INC, but we have to really have a broader plan, because the dynamometers and all are a costly equipment. Its maintenance practices and operations are little more challenging with the emission measurement equipment coming into place. So that will require a well-trained professionals to be placed over there. So it can be taken at a long run, maybe still on a later phase. But I think the use of the RSD and the data coming out of it being collaborated with the existing PEMs and all can be a good way of taking it forward.
Absolutely. That's wonderful, Mr. Mathai. Thank you so much. And I certainly hope, as you can see, that there is so much interest now in different cities, and they are also going to get the mandate to implement remote sensing now. So ARI, I'm sure, will then play a very big role in providing that technical guidance to the city officials and the departments to implement that program. So I think that's a very big opportunity that is emerging in the horizon right now. So thank you, Mr. Mathai. I will come back to you with more questions later on. So now, again, we now go to the global arena. Mr. Yang from Hong Kong. Yes, we are very keenly looking forward to listen to about the initiatives in Hong Kong.
Okay, thank you. Hello, everybody in India. Are you listening to me well? Okay, yes. So I'll share my PowerPoint slides in here. Mm. Okay, I'm not sure if you can see my PowerPoint in here.
Yes, we can see.
Okay.
I think Dr. Yam, you need to, yeah, thank you.
Okay. All right. So my name is Yam. Hi, everybody in India and in the US. I'm from the Environmental Protection Department of Hong Kong, and we are with the Mobile Source Group of the Air Policy Division. Oh. Okay, today I'm going to talk shortly about the remote sensing enforcement program we have been in place since 2014. And I'll cover the basic facts, the baseline information, and what technology we use in the program, and some figures generated from the program. And if there's time is allowed, then I cover some of the recent developments in the diesel remote sensing. Right. So this is what happened before the remote sensing enforcement. Basically, we have a lot of excessive emission from the LPG vehicles. Excessive by means that they exceeded their design standard by many times. And even though they have a very small vehicle population, but they produce significant pollution contributions. So in terms of a population, by the time of the measurement, the LPG taxis and the light buses only cover about 4% of the vehicle fleet compared with.
I'm sorry to interrupt. Can you please put your slide on slideshow mode, please?
So you're not seeing the slides?
No, we can see your slide, but can you put it on slideshow mode so that it becomes, we can see it properly?
Full
Well,
screen.
display mode, that's why it is happening like that. He will have to change his.
Okay, fine. Carry on. Doesn't matter. Carry on.
Okay. Okay. So, so what we did is we did a baseline survey of the vehicle emissions, and we use a portable dynamometer and test several hundred vehicles, including the petrol cars and LPG taxis that we have on the road. And they are selected randomly and using a portable dynamometer. And across the vehicle emission standard of the cars and taxis, we found that the older taxis, they have almost 100% failure rate at the time of the survey for the baseline. And compare that with our private cars, which is basically the same emission control technology. They have a much lower failure rate. And basically because of the mileage that is covered by the commercial LPG taxis, they typically run 10 times more miles. And they contribute a lot of pollution in the urban areas. So, with those failing vehicles, we did an emission repair benefit studies, and we sampled about 560 taxis from the fleet, and analyze the causes of their problem. And we did the emission tests on transient dynamometer before and after the repair. Basically, before repair, 91% of those vehicle samples failed, and mostly are related to catalytic converter and oxygen sensors. And you can see that there are severe damage in the converters and malfunctioning oxygen sensors. And then after the repair, the repair we did was we basically replaced these two items, and then the testing shown that the fleet only have only 7% failure. That is a drastic decrease after the replacement of the converter. So we expect there will be a significant emission benefit after the replacement. And eventually in 2013, we the government provided a one-off subsidy for all the taxis and light buses to replace their converters and oxygen sensors, and that cost about 80 million Hong Kong dollars. So the lesson that we learned from this study is that all these taxis and light buses, they need to go through scheduled regular annual inspection. And obviously the mechanism isn't effective at all. And because there's big incentive for them to cheat just to pass the test on that day. And that would be a typical clean for a day syndrome that we heard for so many years. And it's still happening. So that's why we decided that there should be a targeted dirty vehicle program. And and we decided to use for remote sensing gross emitter screening. And those who found to be gross emitting will need to go through dynamometer testing. Okay, so basically the technology is for the dynamometer, it's basically we use a bar 97 grade VMAX transient test. And the test cycle we selected is a drive cycle, a 200-second drive cycle. And it's designed to correlate with the NECT drive cycle at that time. And we have centers setting up this kind of a dynamometer, and these centers are operated by private sectors, but the centers are designated by the government. Okay. We have selected to use the transient test in this case, mainly because we found that if you want to correlate the remote sensing technology with the dynamometer test result, you need to use a transient testing instead of a kind of a steady-state ASM testing. And this is the remote sensing equipment that we are using as of today. So we have the mobile deployment set up. So we didn't have any fixed site remote sensing sites. They are selected single link sites, and we have over 100 sites throughout Hong Kong to select from. And each day we typically do 3 to 4 shifts per day, and these equipments are operated by our contractors, and they don't operate 9 to 5. They operate more than 16 hours per day, even in the evening. And then also we have a unique dual remote sensing setup. So in each site here, we have 2 units deployed. You can see from here, the first unit and the second unit deployed at the same site. So when we screen the vehicles, so only those vehicles failed in both remote sensing machines will be classified as a fail. That means even one machine says a high emitter, the other machine say the other way, otherwise, then wouldn't classify that vehicle as a high emitter. And the beauty with remote sensing and dynamometer is that they work in tandem, because if you select a correct remote sensing cut point, then you can match quite well with the dynamometer emission test results. Also, the dual remote sensing that we deploy is a fail-safe. And we also set a fail-safe cut point such that when on road, when the remote sensors classify a failure, we ensure there's no false detection or no false failure. And of course, the benefit of the technology themselves is when you have a dynamometer, it's a more efficient compliance test compared with an idle test or no-load test. And we set the emission limit for the dynamometer test is 2 times the vehicle type approval limit. And they are cheaper to test, quicker to test. And also I stress that you must use a transient test cycle to correlate remote sensing. And of course, the benefit of remote sensors have been covered by other speakers. But the key point in our program is that we will set the remote sensing cut point with 0 error of commission. That's the key point for the for this program. So I explained briefly how we determine the remote sensing cut point. So the remote sensing cut point is entirely determined by the dynamometer test results. So if we set up vehicles on a dynamometer test on a transient test cycle, you find that the emissions are not steady but very transient. Typically a peak or transient emissions would dominate the overall cycle emissions. So in each of the dynamometer tests, we collect information of the peak hydrocarbon. So this is 99 percentile of the whole time series, and also the gram per km of the whole program, the cycle test. So with these two information, then we can set a chart like this. This is the dynamometer test gram per km results. On the left, oh, sorry, it's okay. On the left side here is those vehicles that pass the dynamometer test. On the right side, that's the beyond higher than the cut point of that vehicle. These are the failed vehicles. These are the gram per km information that we collected from this dynamometer test. Also, the peak emission information will be put on the y-axis. And you'll find that for all those vehicles that pass the test, there's a kind of an absolute maximum of the peak emissions that you'll find on those clean vehicles. On the dirty vehicles, you also be able to find the peak emission concentration, but some of them will be higher than the clean vehicles. There's a red line here. So with this red line, it will correlate the peak emission with the gram per km cycle emission results. And from this quadrant plot, you find that if a vehicle, when passing through remote sensing equipment, generate a emission level higher than this this remote sensing cut point, then we'll classify it as a fail. And for those vehicles that's lower than the emission peak remote sensing cut point, they will be a clean vehicles. And on this quadrant here, if you have a remote sensing measurement at this location with a very high emission concentration, but with low gram per km result, that will be the error of commission. So and on here this is the error of omission. That means that some of the failed vehicles, the vehicles that failed the dynamometer test, they may not generate a significantly high emission peak. So we have some certain percentage of error of omissions. But the key point in the program is that we set this red line here, the cut point, to make sure that there's 0 error of commission. We don't want to see a false failure by the remote sensors. Okay. So this is a typical program operation schematics. We have the mobile setup of the device on the road lane, and these two devices are connected into a set control computer. The remote sensing device is similar to others that we've seen before, and with the license plate recognition system. In here, we use the infrared technology to measure the vehicle number plate, so that we can measure, carry out the enforcement even without daylight or sunlight. So the computer will match the emission results and through a network to send the data back to the office server. And with the data in the server, we match the vehicle information with the Transport Department server and find out the appropriate emission cut point for that particular vehicle number. Because we know the license plate number, then we know the what sort of emission standard they should achieve. We also measure the speed and acceleration of the vehicles to make sure that we do not, if the vehicle is under off-cycle condition, then we will drop that data. Well, with the analysis, then we can issue the notice to those vehicles who fail the remote sensors. And I must stress again that the vehicle must be failed in both machines. For those who only fail in one machine, we do not classify them as failure. And with the notice, this notice is sent to the owner, and they have to bring the vehicle to test in one of the private test center using the dynamometer test. And if they fail to comply with the requirement, either passing the test or bring the vehicle to a test, we will inform the Transport Department to cancel the vehicle license. And this is the only penalty that they will have. So sorry.
Sorry, you have many slides. If you can just hurry up because we have two more presenters after you. So
okay.
That would be very helpful.
Yeah. Okay. So just a quick timeline of what we did is that before the program implemented in 2014, we have the remote sensing baseline result of the both the private cars and the taxis. And we said that on road, we screen about 45% of the taxis as failure. That's including not including the error of omission. So typically, the dynamometers say that about 90% of those will be failed. So after we replaced the oxygen sensors and the for the converter for the LPG vehicles, we start to implement the remote sensing program in 2014. And in 2016, we checked the baseline again. There isn't much change in the private car sector, but for the LPG taxis, the failure rate dropped by almost 5 times. So this indicates the replacement of converter is very successful, and the implementation of the enforcement has kept the vehicle clean all along. So from the program implement to the end of last year, we screened totally about 4.7 million vehicle counts of the petrol and LPG vehicles, and we issue about 24,000 notice. And this is a breakdown of the vehicle fleet. Most of the failures still stay with the taxis. But notice the passing rate when the program just implemented in 2014, the passing rate for the dynamometer test is only 50%. But by the end of last year, almost 99% of those will be able to pass the test. That's related to the trade that they managed to repair the vehicle properly. So the key summary for the program is that we have the site deployment just according to the vehicle capture, because we know that the LPG vehicles are our major interest. So we'll move around the sites to maximize the vehicle captures. And the setup of the cut point for the remote sensing is to aim at 0 error of commission. So, and also because the dynamometer only tests the failed vehicles, there will be no more annual or universal tests. We don't test any clean vehicles. We don't do any clean screening. We just screen the dirty vehicles and test them. So the costs for the remote sensor operation is covered by the government, but the dynamometer test field is paid by the owner. So they will test for every test they carry out. To further compare the benefit of the remote sensing program, on the left side I have a chart of the NOx measurement of the remote sensing. Most of the failure in our fleet is related to NOx. Before the program implement, the average LPG vehicle emission of the NOx is almost at 1,600 ppm. After the replacement and enforcement, this the LPG NOx emission concentration dropped dramatically. On the right side is the roadside air quality data. And we also see a similar drop in the roadside NOx that's measured by our air quality stations. And that is also in sync with the remote sensing program. And of course, we do have other programs in place as well, right? So from these two data, we know that the remote sensing with the monitoring results do have a very comparative pollution trend at the roadside. And that is still effective in reducing vehicle emissions. So if you want more information about this program, we have a paper coming up, so you can stay in tune and look for that paper. And more information of the program on our website. That will cover the remote sensing dirty screening. But I want to bring up just a couple of slides that we've done lately on the further development of the remote sensing technology.
Quickly now, because we are really running short of time. So if you can quickly wrap this up.
Okay. So the development we have is to using the remote sensing technology to quantify the air quality impact. The test we did was we have the air quality sensors measurement alongside the remote sensing equipment. And this is the result that we measure at the roadside. The line here represents the air quality sensor data, the NO2 and the NOx data at the roadside. And this is the across the concentration spectrum. And the main values are on the right. And the bar here is the remote sensing data result. You see that this the measurement is the mass unit rather than concentration of NOx. That will be a direct comparison of the emission from the tailpipe and the associated air quality impact. And you will see that you can see that the remote sensing data match correlate closely with the air quality sensors results. And if we sum up this chart here, that's what we attempt to do is to see which vehicle classes cause most of the roadside air quality pollution. And, okay, most of the emission will be from our franchise buses. Almost 70% of NO2 pollution is caused by the diesel buses. And for other diesel vehicles, the pollution is up to 80%. So right now, most of our roadside NO2 pollution is caused by diesel vehicles. And that's the latest one that I want to cover. So thank you very much.
Thank you so much, Mr. Yam. I'm very sorry for rushing you, but in a webinar mode, the time is so tight. But it is so impressive to see this very robust program in Hong Kong. And what I really like, the hard evidence to prove and demonstrate the impact of the program in terms of improvement in emissions and air. It really convinces all of us, the power of this intervention. So thank you very much, Mr. Yam. Look forward to hearing more from you. So now I quickly move on to, Deepak Agarwal. So if you tell us.
Yeah, hello. Can you hear me?
Yes, we can hear.
Okay, greetings from India. So I just want to give hi from myself to my fellow panelists and attendees. So let me just share my screen. Can you see my screen?
Yes, we can.
Okay, so I will try to
do full screen.
Okay, so I will be little concise since most of the topics have already been covered by my fellow panelists. So today I am going to discuss about the remote sensing project that we did in ICAT 2 years back. This project was funded by Department for Heavy Industries. So it's more like a pilot project where we have to just prove the concept and how we can do it in India. So these are the broad contents that I will be covering. What is the importance of in-use emission screening? Why do we actually need that? A little bit about remote sensing and a little bit about what we did, how we did, and results that we got. So this is one of the studies that was conducted in Europe related to figuring out how the real world emissions differ from the regulatory emissions that OEM car companies generally certified. So as you can see that the emissions that we get in the city driving cycle at 23 degrees centigrade is 0.35 grams NOx per kilometer. So all these testing have been conducted in the lab. So there is no real world driving. So as you can see that in the congested city cycle, we get the NOx of around 0.35 grams.
Okay, you froze in between. Okay, carry on.
Yeah, and in another cycle which is conducted at -7 degrees, the NOx that was got is 0.95. So you can clearly see the difference, how the real world emissions are different from whatever the OEMs or car companies are certifying their vehicles for. This is the case for the NOx. However, if you look at the case for PM, the PM emissions are more or less in line with the regulatory requirement, and in fact in some cases much less than the regulatory requirement, which is 0.005 grams per kilometer. So this is mainly due to the fact that all the Euro 6 vehicles have been fitted with DPF. So there is no possibility that the particulate matter can escape unless the DPF is defective, while the OEMs have some leeway on how they want to control the NOx. So that's why we are getting this big discrepancy on the regulatory requirements and the real world NOx emission. And the same is the case with CO2. For different cycles, we are getting higher CO2 as compared to whatever the OEMs are certifying their vehicles for. In the similar study, the research institution find out that the whatever emissions are produced by the heavy duty is significantly less than the for the passenger car. And this is mainly due to the fact that in heavy duty vehicles, during the vehicle or engine tuning or calibration, we are covering the much wider envelope of engine map as compared to the passenger car vehicles, which is certified as a light duty in the light duty category. So a little bit about remote sensing. I think this topic has been covered in the by the previous panelists, so I'll just go through that. So here you can see that the car is coming on the road, and here we have set up the RSD device. So RSD device comprises of camera. Can you see my cursor?
Yes, we can.
Okay, so this consists of a camera. We have the speed and acceleration, vehicle acceleration measurement device. So here is the source module that basically sends the light beams, and this is the detector module. So whenever the vehicle passes through between these two light beams, the RSD comes to know that there is some vehicle that is passing through it. And once the vehicle interrupts these light rays, the camera captures the image of the license plate, which is like this, and these two are the emission analyzers. So this is the source module, and this is the detector module. So the source module sends the infrared and the UV rays, and whenever the vehicle passes through that, exhaust gas passes through the light beam, the light beams are absorbed by different pollutant gases, and whatever comes out after absorption is detected by the source module, and the difference between the source and the detected module, it figures out how much pollutant the vehicle is emitting. So a little bit about what we did in ICAT when we did this project. So we have basically divided this project into 3 parts. The first was the planning and preparation phase. Here we have basically planned the sites where we want to implement the RSD. So we have to ensure that the RSD device does not hamper the traffic, because no government authority will allow us to put the RSD device on the road. So we have to make sure that RSD device doesn't hamper the traffic movement. And the second was that we have to ensure that wherever we put this RSD device, there is sufficient exhaust coming out from the vehicle so that the RSD device can detect the exhaust plume. So usually what happens if the drivers come to know that there is a RSD device installed, they usually put or remove their foot from the pedal and let the vehicle roll through the device. So in that case, RSD will not detect the emissions. So it's very important that wherever the RSD device is installed, the driver should be either accelerating the vehicle, or he has his foot on the pedal, so that the combustion is happening inside the engine cylinders. So once we have decided the site, we have to take the approval. So this is also a big task, because we have to make the authorities understand what we are doing. So in the second stage, we have collected the data on the actual vehicles. So in this case, we have collected the data for about a month, and then we have characterized the emissions by defining the cut points. So once a vehicle passes through the RSD device and it has the emissions above the cut point, then we have provisions to pull over the vehicle and inspect what is wrong with it. Although it's not a very sophisticated pullover inspection, we have just got 5 gas analyzer, and in some cases the driver also refuses to let his vehicle inspect by us. So this is very limited scope vehicle inspection. So in the third stage, once we have all the data, we have collected everything what we want. Then we have to match the vehicle emission data which is collected by the RSD device against the whatever vehicle information that is stored in the Vahan database. So this we did in the vehicle matching activity. And once we have the vehicle details matched with the corresponding emission data, we did different data analysis. And in the final phase, we prepared the report and presented it to our sponsor. So in total, we have chosen 5 sites, and all these sites are the toll plazas for the roads which are basically catering to the NCR region. So as I mentioned before, that our main idea is that in the toll, the lanes are properly defined, so vehicles are segregated, and there is no way that we can congest any particular lane on the highway. So, and the other reason is, once the driver gives the toll to the booth, he tries to accelerate his vehicle. So in that way, we also make sure that the driver is accelerating the vehicle. So he cannot fool the RSD device by just letting his foot from the accelerator pedal. So in total, we have captured around 300,000 vehicles data. Out of that, we have to discard some of the data because either the vehicle registration plates were not proper, or we could not capture the emission data, or vehicle speed or acceleration limits are beyond the permissible limit of RSD. So in addition, we have also captured around 16,000 vehicle data, but we could not associate the vehicle details for this data because we could not either capture the vehicle information from the registration plate. So these are the setup pictures. I just briefly go over the results. So these are the results for the valid records. So here you can see on the x-axis there are different emissions, and on the y-axis is the pollutants. So we have scaled different emissions by some factor so that we can fit them all in one scale. So as per Vahan database, we have characterized the vehicle types in different categories. So HDV means heavy duty vehicle, and this is the fuel type, and LDV means light duty vehicle, followed by fuel type. So here we can see that for diesel vehicle, the CO and SC are way below than the CNG or petrol vehicles. So this is basically the combustion chemistry, and this is expected. But however, for the HDV vehicle, which is this orange line, we found out that the emissions are more or less closer to the petrol vehicle emissions, like here. So in this case, we came to the conclusion, because of the poor maintenance of heavy duty vehicle, the emissions for CO and SC are high, and for NOx and UV smoke, the emissions for diesel vehicles are significantly higher than as compared to CNG or petrol vehicles. And again, this is related to the combustion chemistry. So this slide shows the model year in which the vehicle is manufactured compared against the emissions. So here we can see, as the vehicles get newer, the model year moves to the more recent one, the vehicle emissions tends to gets better. So you can see the emissions are coming down in the newer vehicles. So all those these zigzag lines are due to the fact that we could not collect good number of data for heavy duty CNG and light duty CNG vehicles. So similarly, for this is for the CO, and this is again for SC. The trend for the emissions more or less remains the same. So as the vehicle gets newer, the emissions tends to get reduced. This is for NOx, and this is for PM. So as you can see again that for LDV vehicle, which is this line, the NOx emission more or less remains constant, although we have moved from Euro 2 to Euro 4 at this point, 2018, but NOx level more or less remains the same. So this is again pointing to the first slide that I have showed, that the real world for the NOx emission doesn't move in relation to the legislation or tighter emission legislation. This is the emission distribution graph. So here we can see that on the x-axis we have the number of vehicles, and this is the corresponding pollutant concentration, CO in percent, and rest other are in ppm. So the way to read this graph is, let's say if I take this graph, so 50% vehicles are polluting, or they are emitting less than 1000 ppm NOx. So you can see that more or less the good vehicles, they are not polluting much, but there are only few vehicles that are causing the pollution. So we have captured this data here. So you can see that if we remove 99, or if we remove 1% of the polluting vehicle, we can reduce CO by 89%, SC by 91%, NO by 64%, and smoke by 70%. And similarly, if we remove 5% of the vehicle, we can bring down the overall CO emissions from heavy duty vehicle by 92%, SC by 99%, NO by 71%, and smoke by 84%. So this is for heavy duty diesel. Similarly, for light duty CNG and petrol emissions, we have come up with the numbers. So 1% vehicle is causing 67% CO emissions, 89% SC emissions, and 62% NOx emissions, and 98% smoke emissions. So whatever thresholds we need to decide for the RSD, once we implement this program nationwide, we have to come to the understanding what these limits are, whether we want to capture just 1% of the vehicle fleet or we want to go with the 5%. So for this project, we have chosen 5% vehicle should be captured for the pullover inspection. So this is something that that needs to be put into the AIS document based on the fleet characterization of the entire, let's say, or sample fleet that is running in a city. So I think that's all I have. Thank you.
Thanks a lot, Deepak. I mean, this is so important to have this evidence from our own city. And particularly when we get such deep insight into the fleet profiling that you've done, and this very strong message that by targeting just 1 to 2% of the vehicle, such big emission benefits you can get, that whole worst emitter identification that we're all talking about. So we will certainly come back to you again on this issue, but I'm also looking at the time. So we'll extend the time a little bit and want to hear now the last speaker of the day, Mr. Li Kungsheng from Beijing. Yes, Mr. Kung, I know there is so much to share from Beijing, but if you can very quickly capture the key strategies that you have implemented, that would be wonderful.
Mr. Quinsheng on mute.
Yes, Mr. Li Kungsheng, you are on mute. Can you unmute yourself? You are still on mute, Mr. Kungsheng. We can't hear you. Yes, we can see your screen.
Yeah, can you see my PPT?
Yes, we can.
Yeah, okay.
Yes, we can.
Yeah, hello everybody. Now, now I'm briefly introduce of some of the Beijing situations. Sorry. Yes, after the hard working nearly 20 years, Beijing the air quality continue to improve. Yeah, and but I think the most part of the pollution resources from the vehicles. You can see these pictures. I'm sorry. And from the last year, we made the new regulation on the pollution prevention and the control from the motor vehicle and the no-roller mobile machinery. We have implementing the national six the B programs in Beijing the last years, and same time so we carry out the law enforcement and the supervision of the new vehicles in order to that they met the emission standards. and a number of the enterprise have been punished. I think the most effective way is the manufacturer of the vehicle to obey the new standards. So in 2020, our bureau coordinated with other provinces and cities from, for example, the Hebei province and the Tianjin city, to altogether to implementing the new standards, the national 6. And at the same time, so we supervision of the on-road vehicles and the intro inspections, the bigger the transmitter the company. The vehicle in use, we also use the remote sensors and to check the smoke in Beijing area. We have established more than 100 sets to. Sorry. I'm sorry. I'm sorry. We have 100 sets of the remote sensor detective point for the vehicle emissions, mainly in the local the road of the more vehicles, including the 19 diesel vehicle black smoke capture points, which can be judged through the image of the exhaust ringman, the blackness. The local standards for the remote sensing detective of the gasoline vehicle have been implemented more than nearly 20 years. More than 40 billion pieces of the valid data have been detected every year. The vehicle found exceeds the standards by the remote sensors detected will be handed over to the public security, the traffic management department. In the first half of 2020 alone, nearly 500 vehicles have been punished. The strict inspection was carried on the annual inspection agent by on-site inspections, background, the network, the monitoring, analyze the process data. Verification of the environmental parameters, reviews of videos and the recording and the other methods to crack down the illegal activities. From the year 2018, the 87 agencies had been punished. The fine was more than 5 million yuan. And I think one of the most important the way is to retirement the older vehicles. From the year 2017, we implementing the subside policy for eliminating the European 3 diesel trucks, and from the last year of the April, implementing the subway to eliminate the European 3 gasoline vehicles. And the traffic restriction for the high emission vehicles, we set up the low emission zone in Beijing area, in downtown area. From the year 2017, we forbidden the gasoline 1 and gasoline 2 European standards the vehicle to enter the fine ring of the Beijing. And the same year we forbidden the heavy duty vehicle of the European 3, the Bellow, to enter the ring 6. Yeah. And maybe you are interested in the way from the year 2017, we began to experiment with the remote emission monitoring heavy duty vehicles, build the monitoring platform, and publish the local standards for remote emission monitoring of the heavy duty exhaust pollution emission limited and measurement method, the local standard. After the 3 years hard working, and we set up the platform for heavy duty vehicles, mainly in the focus on the diesel vehicle. And in this platform, Beijing realized the function of the remote emission monitoring and the data of the NOx emission, OBD alarm, the urea level, and other vehicles have been transmitted to the remote emission monitoring platform of the Bureau in real time. The remote emission monitoring and the management on board the terminal install for heavy duty vehicles can collect the data of the NOx emission, OBD alarms, urea levels, speed, engine torque, speed, and so on. And the monitoring the frequency is the 1 Hertz. And the remote the emission monitoring can reduce the frequency on the manual detection of the heavy duty at the same time. In addition, it can detect the excessive emission behavior of the vehicle pollution in time and reduce the pollution emissions. Nowadays, 80,000 heavy duty have been monitored remotely online. Implementing the local standard of the gas emission of the gas stations, the oil stuff. Maybe this part of the fuel recovery, the vapor recovery, not the topic in this seminar. So thank you very much. Okay.
Thank you so much, Mr. Kukshen. I mean, you know, it's so fascinating to see that you now have capability to remotely track a vehicle and track its on-road performance real time. You know, I think that's where the world is moving, and that just shows the potential and the opportunity of this technology. that one is to do the roadside surveillance and analyze the data, but here you are actually tracking the OBD and the vehicle and tracking so many different parameters remotely and giving the feedback. I think this just gives us the idea about, how transformative these interventions are going to be in future. Now, I do understand that we are really very late, but this has also been one discussion where I think we were all very hungry for the knowledge and the information that all of you had to share with us. Because here we just did not want to interrupt you, because this is a great opportunity to have all of you together in this platform, listen to you, understand your information, your experience, right? And so I'm glad that we have been able to give this the time that it requires to listen to all of you. So what I'll do, because I know our Q&A box, our chat box are flooded with comments and questions, which we cannot take up right now, but I would like to assure everyone that all the information that you have shared with us and the comments, that we will share that with our speakers, and wherever you have specific questions, our speakers will get back to you. Now, because we cannot do discussion, because that's going to take a lot more time, I think I just take one opportunity to ask all of you one common question and give you 1 minute to answer that question. And that is that if you want to convince a city authority, okay, and give them 3 arguments that why it is so important to adopt this new generation technique for on-road emission monitoring and real-time emission monitoring and action, what will be those 3 arguments that you would want to put on table? So if I go one by one, I don't know whether Mr. Sinha is still with us or not.
Oh, I'm still there.
Oh, yes, Mr. Sinha, please. We would.
In fact, yeah, I'm here.
And Mr. Sinha, actually, maybe this question is not even appropriate for you because you're already convinced and you are doing it. So maybe in your case, it is more about your next steps and how do we take it from Kolkata to beyond. So if you can reflect a little bit on that first, and then other panelists can reflect on the other question.
Yeah, thank you very much. In fact, I have already mentioned that we are already thinking of introducing 2 more such systems in our city very soon. And as soon as the results start coming in, we can also move on to other districts, other cities which are larger in nature where more polluting vehicles can be found. It not only gives us a way to enforce the vehicle quality, emission quality, but it also gives us a very good tool for planning for the future. So government of West Bengal is already convinced, and we are working on this. And I hope as soon as the COVID things subside and the economy recovers, we'll be able to introduce immediately a couple of more machines in the city itself.
To that, Mr. Sinha, if I can just add one question, which is on everyone's mind, that in Indian cities, how PUC and remote sensing can coexist. So do you have any specific comment on that? I see some questions related to that have been asked. So do you face any problem with that?
No, absolutely. These 2 things are interrelated. You see, remote sensing gives us the vehicle pollution levels. And if we just get this data tagged with the data in the Vahan software, so we know actually which vehicle is emitting what is the details of the vehicle, what is the engine type, what is the fuel type, how many wheels are there, and so many other things can be correlated, and we can actually find out which class of vehicle or which brand of vehicle is more polluting, and we can take action accordingly. So once we know the actuals on the field, we can very well enforce the pollution under control, the norms, as well as we can use this for planning for removal of certain vehicles, or telling the manufacturer to introduce something new in the vehicle and things like that.
Absolutely. I mean, thank you so much for sharing that with us, Mr. Sinha. Yeah. We are all looking forward to your future plans and your interventions. Thank you. Thank you very much.
Thank you very much.
Thank you. Tim, you would want to take that question?
Yeah, let's leave everyone with a few high-level thoughts. And I think kind of the key message I would try to get across is that data is power. So for a long time, we didn't know anything about real-world emissions from vehicles. There was limited ways to get that information, and those methodologies weren't widely deployed. But I think in the last decade or so, we've really seen the expansion of different types of methodologies being developed to understand real-world emissions, and just a lot of data coming in from all over the world. So I think that's the first step in developing effective policies, is really understanding the problem. And I feel like these technologies like remote sensing are a very effective way to do that. And I think from all of the speakers today, we were able to touch on a few of the applications of those data sets, but kind of taking the steps to collect those and inform the right people of what real world emission levels are is the first step to take action to address those emissions. So I think I would just leave that as my key point, that it's so important to build support, to build the knowledge base that's necessary. The first step is to actually make those measurements, and everything flows from there. And I think looking forward, I think thinking about how we can continue to develop these methodologies, I think kind of Mr. Kunsheng's presentation of the remote OBD is so important, because there's kind of this idea, if you have that information in real time from across the vehicle fleet, there's so much more you can do to try to limit emissions and limit the negative impacts of those emissions. So I'm very much looking forward to seeing how this develops, and I'm hoping that everyone here today can take away some of the key learnings when it comes to the importance of real world data collection.
Thank you so much, Tim. I think, yeah, exactly the right message that you have for all of us. And absolutely, and we are also looking forward to it as you are. Mr. Yang, what are your thoughts?
Yes, well, I do echo the point made by Tim, but that the data is power. We've been doing the remote sensing monitoring since 1993 for almost nearly 30 years. Well, but to align the people from the authority or from the academia or professionals, we need to make sure that some of the knowledge is coming from the data. And the important thing about real-world emission is that the emission from vehicles, they vary so much. If you take a vehicle to measure it in the lab on a dynamometer, it probably generate one set of results, but different from what you can find from the remote sensing data. So the technology will allow us to look further from what's being used currently. And also because the remote sensing is very cost effective, the cost is not that much, really. So and most of the professionals agree that we will find a converging result on, say, vehicle models, vehicle fleet, or even to individual vehicles. So I think the point is, start earlier and start gather data, and we start seeing the trend, just like what we're seeing here. Yeah.
No, very good point, Mr. Yam, and the fact that you're saying that it's actually going to be cost effective, because the general impression here is that maybe the investment and the expenses are going to be the big barriers. But from the scale of operation and application and the effectiveness of the strategy that you have talked about, I think, and the fact that it can be cost effective with the scale of the operation, I mean, that's a very powerful message for our authorities here. So thank you very much, Mr. Yang. I think Mr. Mathai had to leave. So Deepak, your thoughts?
Yeah, I think based on the experience, what we have gathered for 6 or 7 months during this project activity, we realize how important it is to implement RSD, especially in India, considering the fact that 20 out of 14 out of 20 cities, most polluted cities are in India. So this also gives us the opportunity to characterize whether the pollution is coming from the vehicles and how to mitigate the impact of the pollution that is coming from the vehicles. So the other fact is uh, at the moment we are not sure how different vehicles they are causing the pollution. So even if the vehicle is well maintained, Euro 2 vehicle or Euro 3 vehicle is well maintained, but we still classify it as a polluting vehicle just because it's Euro 3. However, Euro 6 vehicle can also be more polluting than Euro 2 or Euro 3 vehicle. So at least if we have such kind of data, it will help us to understand where the pollution is coming from, whether it's a particular vehicle type that is causing more pollution as compared to other vehicles. And moreover, on top of that, if we have this data, then we can definitely use this data to form good policies. We can maybe combine this data with the vehicle scrappage policy that we have just implemented. Maybe we can also use this data to implement vehicle insurance policies to intensify let's say give incentives to the owner who basically do regular maintenance and proper repair of their vehicles. So I think once we have this data, then definitely we can find n number of use cases on how to use them and how to basically implement good policies.
Deepak, I mean, you're very right on. I mean, that's to measure the emissions and understand where we are making the difference. And I certainly see your role and ICAT's role to be so important in future, that now as cities begin to implement and begin to plan for implementation, I mean, that's where your knowledge and your inputs and your contribution is going to become so important. And that's something we are all looking forward to. Mr. Lee Kung Sheng?
Yeah. Yeah. I can hear you.
So what is the key message that you want to give us? A very short message, that what is the learning that we need to understand from your experience and what cities should keep in mind while implementing these strategies. So the key message from you in 1 minute.
Yeah, maybe I think nowadays, after every country or the big city, implementing the European 6 standards, maybe I think now from the diesel vehicle, especially the heavy duty vehicle, the smoking is not a big problem. I think the NOx emission may be the big problem. So I think most important work for the control the emission of the vehicle is must be focused on the NOx. So we set up the platform to modify the heavy duty vehicle in the real time. I think this is the most important nowadays. So in China, especially in Beijing, according our regulation, our standards, the new vehicle must be installed the OBD, the monitoring real-time systems. I think this may be more important than the remote sensor test. You know, you must know every heavy-duty vehicle, especially the diesel vehicle, the real-time emissions, and you can more better control the emission from the heavy duty vehicles. So I think nowadays the remote sensors, most country using the data to do the analyze, not using the punished, because every country, most country using the regular test for the private car or for the private diesel cars. I think, for example, in China, only one way for the one way to control the private car, only the regular test. So I think although the big cities install so many remote sensors, but not used very well, you know. Only do the analyze the data, not punish, not using the punish over the standards. So I think maybe the most important useful way is to monitoring the NOx from the heavy duty vehicle, diesel vehicles. That's my comments. Yeah.
Absolutely. Thank you so much, Mr. Lee Kung-shen. I mean, yes, so many points that you have made, but the key.
Pardon, I have maybe I can't because my English is not very well, so maybe I can't explain very clear my presentation. I can show you one video, but in Chinese, how the Beijing the monitoring platform to work. Do you interesting?
So
I can show you the video. I can show you the one video.
So Mr. Lee Kung-shen, I mean, we would love to do that. Only thing is we are very short of time and we have to wrap up now. So we have to end the session now. So we don't have time for that video, but I will encourage you to share the video with us so that we can share the video with all the participants and they can take a look at it. I mean, we would have loved to see this, but just because we are really running against time at this moment, we need to close the session. So, but what you have said, you have given us so many different strategies that you have shared with us, but one compelling message that we get from you is that how much effort you have made to focus on applying these new generation techniques to establish compliance and accountability in the system. This whole remote monitoring and the scale of its application, it's so powerful and it's already showing up in your data. And I think that's something that should convince all cities today in India when they are planning their next steps, that's such vast learning now that exists in different parts of the world. And what we have just heard, this is only a bird's eye view. And if we get a chance to do a deeper engagement with each one of you, which we will, as we keep getting into this deeper and deeper, I think that's an amazing opportunity for all of us. So what I will do, I will not even dare to attempt to summarize because all of you have given excellent concluding remarks and your presentations themselves have been so articulate, so powerful, so data rich, and so evidence driven. And I think that has already given us the key message. All that I just want to say that in India, because that's the takeaway for our Indian audience, that today, finally, India is moving in that direction where we are beginning to set targets, measurable targets for air quality improvement. So when all the cities in this country today have been given a target of reducing their pollution by 20 to 30% by 2024, In fact, that is now getting translated into actual microgram per cubic meter of pollution concentration to be reduced per year in a city. That is the kind of target setting that is happening in India right now. But all of that can be implemented if we have a strategy and system in place to make everything measurable and verifiable. And the new technologies that are emerging now in the horizon, what you have started to apply already, that's what we need to imbibe and integrate with our clean air program, with our implementation strategy, so that we can make our planning and implementation more data-driven, more measurable, and more verifiable. And that's why all our cities now need to go in this direction, adopt remote sensing measurements, integrate that INM program and compliance strategy, but go beyond compliance also to generate all the data and the usability that we have just heard from everyone, that what are the other things that you can do to design your clean air action. We have to begin to design that. And for that, the kind of capacity, system, data analytic capacity that we have to develop in our city, that's where the investments need to flow. So if all that, these dots now can be joined and it can become together, and if we can develop very clear strategy now for implementation with clear guidance, target setting, and the rich information from all the other countries, that how these kind of programs need to be planned and implemented, I think half the battle will be won. And India will be pretty much on its way to accelerate and match its action on on-road emission monitoring with what it is doing for the new vehicles. So that's the key message for all of us. So with that, we bring this session to close. And thank you, everyone. Thank you. Thank you, Mr. Sinha. Thank you, Tim, Mr. Yang, Deepak, Mr. Mathai, Mr. Lee Kung Sheng, all our audience for being with us so patiently, listening to this whole conversation and debate. And we will share with you all the comments and the response from our speakers. And with that, thank you. Thanks everyone from my team and my colleagues who have put it all together. I had named them earlier. So thanks. It's a big thank you to everyone. We'll stay in touch. Have a great day. So good afternoon or good evening or good night, as it is in different time zones of this.